Okie dokie. One last problem that hopefully will help you solve this and get you ready for a quiz and tests and everything else you know, and get ready for advanced math because this is, like I said, some of the hardest and most important concepts you have to know in trig. Is how to solve for exponentials without your calculator, and yes, also with your calculator, but you have to know how to solve these. So what we're going to look for is for find the solutions. All right, find the solutions to this. Find solutions on the interval from 0 to 2 pi. Okay, it's a little bit more complex because now we have a product of two of them. So you might sometimes won't have this, but we have cosine of 2x times 2 cosine of x. Now, because it's the product, just like algebra, we're going to separate this into two separate equations. So this expression times this expression will equal 0. And that's important to know. So in order to try and find the solutions. So what we can do is we can say that cosine of 2x we know is going to equal 0. And then we also know that 2 times the cosine of x plus 1, that also has to equal 0. If this one equals 0, it's 0. If this one equals 0, that's 0. And that's why we factor and do our algebra back in Algebra 1 and Algebra 2 and any other algebra course you take. So without further ado, we're going to do the easy one first. The easy one I consider is the one where b is 1. And if you notice right here, b is equal to 1 here. This is easy. This is what we call basic. All right, trig problem. This one, b is greater than 1. Not so much. Okay, so without further ado, let's figure this one. I'm going to do the easy one first. So in doing the easy one, we're going to solve for the trig function. We're going to subtract 1. We're going to divide by 2. We're going to equal that to cosine of x. Now, we're going to solve for x now. Okay, solve for x. Solve for x by taking the inverse cosine. So we take the inverse cosine of both sides. We have negative 1 over 2. From here, we solve this using our basic trig stuff, trig identities, and our ratio, unit circle. And what we have is inverse cosine. Cosine is negative in the second. That's when x is negative. All right. And also the third quadrant. All right. So we have right here. And just like all our problems, guess what? We have negative 1, and this is going to be 2. Well, this has to be square root of 3. And right here, this is going to be square root of 3. And so what is this angle going to be? Well, our reference angle is definitely going to be 60 degrees. So that's pi over 3. And that's going to be 2 pi over 3. This other one right here, that one's going to be 4 pi over 3. And that's what we have for our answer there. So right there, we're going to have answers of 2 pi over 3. That's in the second quadrant. And we'll have another one at 4 pi over 3, which is in the third quadrant. And guess what? That is it. That is all the angles from 0 to 2 pi for this expression. Now we go to the more possibly challenging one. So now we take cosine of 2x equaling 0. Okay, cosine of 2x equaling 0. Okay, if we're going to first solve this, just like the other one, solve for x. In order to solve for x, we're going to first take the inverse cosine. So 2x equals inverse cosine of 0. Inverse cosine of 0. Now on this side, our inverse cosine of 0, cosine of 0 is where? Here, okay, at pi over 2, right? Because that's a unit circle of 0 and 1, x and y, cosine x sine y, for those that have been me in class or have been watching a lot of my videos. 3 pi over 2 is the other point because that's where we have 0 and negative 1. So 2x has to equal pi over 2, and 2x has to equal 3 pi over 2. Now from here, because our b value is greater than 1, we're going to be adding our coterminal. So we're going to be adding 2 pi n. Okay, 2 pi n. And honestly, if we wanted to, because these are on other sides, we could make this actually pretty easy. If you want to, and we can go 2 pi n as well, if you want to do that. Or what you could do, because these are pi units away, we could actually just go 2x equals pi over 2 plus pi n, pi n. You can just go pi n. That's another way of looking at it because this is just 1 pi unit away. Okay, and so I'm going to use this one because it's easier. Now we solve for x. So x is going to equal pi over 4 plus pi n divided by 2. You'll get the same answer if you do the other one. Okay, but I'm going to just use this. So now the next thing is now we're going to solve for all the solutions, find all the solutions. All solutions on interval 0 to 2 pi. And so what we have, my friends, is, well, we have n equaling 0, n equaling 1, n equaling 2, and we're going up to, once again, 0. Our denominator is 4 in this case, so we have 4. And it's going to be 8 pi's, 8 pi's. So right here, let's try this out. Well, we're going to have our first one is going to be, and I'll go n equaling 3 as well. When we have this first one, we're going to have, well, x equaling pi over 4. When we plug in 0 in for here, I'm going to change this to 2 over 4. So we plug in 1, we're going to have 3 pi over 4. 3 pi over 4. Notice that you'll get the same thing if you actually did solve this one and went this way. So both are correct. If you did 2, 4 would be 5 pi over 4. 5 pi over 4. And then we have 7 pi over 4. And if you notice, we're not going to get any farther. That is our solution right here. All right, for this set of expressions of pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And guess what? We also have this set of solutions right here, 2 pi over 3 and 4 pi over 3 for our various solution sets. So we have 1, 2, 3, 4, 5, 6 solutions total for this expression right there. Okay? So split this up into 2 different ones. Solve just like you did for everything else. Pretty awesome. And yeah, I hope this helps you out. You can also put this in your calculator, check out the solutions if you want to. But for just saving time's sake, I'm not going to do it here. All right. Well, good luck and God bless in the rest of your problems.